this logarithmic equation. And how do we solve this? It's very simple. I will start by saying, this is the solution of the problem, of course. I'm having y equal to x to the power of 4 exponential 3x tan x. So the fashion I'm going to go about this is to first take the ln, that is the logarithms of both sides of the equation. After I'll be done taking the logarithms of both sides of the equation, I have to differentiate all of the expression, both the left and right hand side, with respect to x. And that's the fashion we're going to do. So this is the process. So I will first say taking the ln of both sides. So I will add ln to the left hand side and also add ln to everything we have at the right hand side of the equation. So this simply means that this ln can take part in this individual term. So I will have the ln of x to the power of 4 plus ln of exponential 3x plus ln of tan x. So what will be the next step? I'm going to differentiate this with respect to x, differentiate this with respect to x, this with respect to x. So if I'm to differentiate this with respect to x, of course you know that the differentiation of y is what? Firstly, I'll take the inverse of this, take the inverse of this. What do I mean by inverse? 1 over y, and then differentiate y. 1 over x to the power of 4, then differentiate x to the power of 4. 1 over exponential 3x, then differentiate it. 1 over tan x, and also differentiate it. That's the fashion. So if I take the inverse of this 1 over y, I will have the derivative of y with respect to x equal to, here I will still have 1 over x to the power of 4 times the derivative of this. If you differentiate x to the power of 4, what you have is 4x to the power of 3, right? Plus, here I will also take the inverse of exponential 3x, and I will also differentiate exponential 3x. And remember, when you differentiate exponential x, the result is exponential x. But when you differentiate exponential 3x or 2x, you have 2 exponential 2x. If it is exponential 3x, you have 3 exponential 3x. Take note of that. Plus, I'll also take the inverse of tan x and then differentiate this tan x. Or you know that the differentiation of tan x is sec square x. Is sec square x. Alright. So here we have y 1 over y dy over dx equal to, we can reduce these things. If this reduces this, we have 1 times 4 over x will be left. Plus, of course, what do we have here? This can easily cancel out with the whole of this. So we have 3, just 3, because 3 times 1 is 3. Plus, this can cancel. So 1 times sec square x is sec square x over tan x. Hope that makes sense. So the next thing we're going to do, remember we are looking for dy over the x, which is the dy over the x. So we're going to cross multiply this y over to this part. So we have dy over the x equal to, this y is going to multiply the whole of this expression plus 3 plus sec square x all over tan x. So what is this y? Therefore, dy over the x equal to, what is this y? Remember that from the equation, y is equal to the whole of this expression. So you're going to substitute this in place of y. So we have x to the power of 4 exponential 3x tan x, let's write it very well, tan x into, here we have 4 over x plus 3 plus sec square x all over tan x. So this is the solution to this problem. I hope this video makes sense, a lot of sense. And if you have not subscribed to my channel, please hit the subscribe button, and I will see you in the next video. Thank you. Peace.